Using the distance form of a line, determine the distance of the point P having the coordinate 4, 1 from a line whose equation is given to us, that's 4x minus y equals to 0, measured along the line, making an angle of 135 degrees with the positive x-axis. Okay, let us begin. So first, let's try to understand the problem graphically. So here we have considered the xy coordinate axis. Let's try to plot the point 4, 1. So here 1, 2, 3, 4. So let us suppose this is the point P with the coordinates 4, 1. Now we have another line whose equation is given to us, that is 4x minus y equals to 0. 4x minus y equals to 0, or simply put, this is a straight line which can be represented as y equals to 4x, or we can say y equals to m times x plus c. That tells us that this is a straight line that is going to pass through the origin since the y-intercept value equals to 0. So let us sketch a line with slope of 4, and that is going to pass through the origin of the coordinate axis. So we have the line 4x minus y equals to 0. So this is a straight line that passes through the origin. Okay, now what our goal here is to determine the distance between the line and the point, and also there is a condition here. That means a straight line is going to pass through the point and it is going to intersect the line 4x minus y equals to 0, and also it's going to make an angle of 135 degree with the positive x-axis. So let's try to sketch that line. So here let's say we have the line L which is going to pass through the point P, and also let's say it intersects the other line 4x minus y equals to 0 at the point Q. Our goal will be to determine the length PQ. The condition here that the line L is going to make an angle of 135 degrees with the positive direction of x-axis. So this is given to us. So what shall we do? So first what we'll do, we'll try to find out the equation of the line L in terms of the distance form. So here we know the distance form of a line that is given by, let's quickly note it down. If we have a line passing through the points x1, y1, and we have another point with the coordinates x, y, such that the distance between the 2 points, that's r unit, then the distance form of a line is given by x minus x1 divided by cosine of the angle alpha added to y minus y1 divided by sine of the angle alpha equals to r. So here alpha is going to be the angle that this particular line makes with the positive direction of x-axis, and this is referred to as the distance form of a line, the distance form. Okay, fine. Now coming to our problem, what we'll do, we're going to apply the distance form to the line L. So let's consider the line L, since the line L passes through the point P and the point Q. So here what we'll do, let the coordinates of the point Q be, let the coordinates of Q be, so here we're going to consider its coordinates to be x, y. Fine. So here we have considered the coordinates of Q to be x, y. Fine. Okay, now we can apply the distance form. So we have x minus, we need x1 here, so x1 will be the x coordinate of point P. So that's x minus 4 divided by cosine of the angle that the line L makes with the positive x-axis. So that's 135 degrees. This is the value of alpha here. So I have cosine of 135 degrees. This is going to be equals to, we need y minus y1. So y1 here is 1 divided by sine 135 degrees. And this is going to be equals to r. Okay. So what we have here is in an equation, given in the equation of the line L given in a distance form. So let us consider x minus 4 divided by cosine of 135 degrees, and this is going to be equals to r. So we can represent x as 4 added to r times cosine of 135 degrees. Now what is the value cosine 135 degrees? So cosine of 135 degrees, this can be also expressed as cosine of the angle 90 degree added to 45 degrees. Fine. So this is going to be equals to cosine, so cosine will become sine since we have 90 degrees here, so we'll get sine 45 degrees. However, by working with cosine function, and 135 clearly is in the second quadrant where the cosine function is negative, so the value of the cosine function, that should be negative, right? So we should get negative sine 45 degree, or in other words, we have negative 1 over square root of 2. Okay, fine. So we have x equals to 4 minus r over square root of 2. So that's the value of x. And next we consider the equation y minus 1 divided by sine 135 degrees. So that's going to be equals to r. So we have y equals to 1 added to r times sine 135 degrees. Now sine 135, so if we apply this rule, then it should be positive 1 over square root of 2. So we get y equals to 1 plus r over square root of 2. So here we have used the fact that sine 135 degrees, so that's equals to cosine 45 degrees, which will be equals to 1 over square root of 2. Okay, so now what we have done here is express the x value as well as the y value in the parametric form. Or in other words, we can say that the coordinates of the point Q, which we initially expressed as x comma y, is going to be given by 4 minus r over square root of 2 comma 1 plus r over square root of 2. Fine. So here we have expressed the coordinates of the point Q in the parametric form. The reason why we did this, because we know for a fact that Q is also going to lie on the line 4x minus y equals to 0. So if it lies on the line 4x minus y equals to 0, it must satisfy that equation. So we have, so what we get? So we have 4 times x, but in place of x, we can replace it with the x coordinate of the point Q. So that's 4 minus r over square root of 2. Then we have negative y. So negative y will be 1 plus r over square root of 2. That's equals to 0. And when we simplify this equation, that's going to give us the value of r. So let's do that. So we have 4 times 4, that's 16, minus 4r over square root of 2. Minus 1 minus r over square root of 2 equals to 0. So 16 minus 1, that's going to be 15, minus, so 4r over square root of 2 minus r over square root of 2, that's 5 times r divided by square root of 2 equals to 0. So we have r equals to 3 times square root of 2 unit. So this is going to be the length of r. So that means we have successfully obtained the distance between the point P and the line 4x minus y equals to 0. So that came out to be 3 times square root of 2 units.